This podcast is brought to you by Buy Me a Porsche, where dreams meet generosity. Think of it like buy me a coffee, but with horsepower. Support your favorite content creators by helping them upgrade from coffee runs to canyon drives. Make a personal donation at www.buymeaporsche.online and help turn our Porsche dream into reality. Check the link in our description below.
What if the smartest technology we've ever built, this quiet, invisible algorithm deciding on your loan, maybe your job application, even your medical treatment, what if it's inherently designed to be unfair? And what if the organizations using it are basically banking on you never figuring out why?
Welcome to the Deep Dive. Today, we're cracking open the stack of sources on AI ethics and privacy, our mission. We're skipping the headlines, the usual noise, and giving you the specific high-stakes knowledge, stuff less than 1% of the public really gets. Like the technical reason AI can feel so biased and why failing to fix that black box problem could cost companies a crippling $35 million.
Yeah, we're really moving beyond just talking about it philosophically now. This is about critical operational risk. We're in this completely unprecedented ethical landscape. You've got massive amounts of data meeting really critical decision making. And that demands, well, not just awareness anymore. It demands sophisticated, proactive governance frameworks. Okay, let's unpack this a bit. Imagine you're caught in some bureaucratic nightmare, right? Financial thing, maybe government red tape. The rules feel opaque, they contradict each other, seem totally arbitrary. You know the outcome isn't fair, but you can't peek under the hood, you can't see the logic. That really frustrating feeling, that sense of random judgment. That's kind of what happens when biased AI makes these big life decisions. Which brings us straight to the first big hurdle. Algorithmic bias. Now, most people think bias is just, bad data in, bad data out. Simple.
It's actually a bit more insidious than that. See, AI is fundamentally shaped by the data it eats, basically. So if that training data systematically underrepresents certain groups, maybe based on race, gender, where they live, the model doesn't just copy the bias, it institutionalizes it. And what's really fascinating now is how the new wave of tools makes this worse.
You mean generative AI, the stuff we hear about writing code or making art?
Precisely. These generative systems, they're trained on these enormous, largely uncurated slices of the internet. So they absorb and then they amplify every existing cultural stereotype, every societal bias they find, and then they repackage that prejudice with this dangerous shine of scientific credibility. It's not just one biased person making a bad call anymore. It's this huge algorithm backed by petabytes of data saying the bias is, objective truth.
Wow. Okay, so how do you even begin to fight that? If the data itself is poisoned, do you just scrap the model?
Well, our sources show it takes some really intense technical work. There's this technique, for instance, called adversarial debiasing. Think of it like training two AIs at the same time. One's trying to do the main job, say, predict loan risk. But the second one, the adversary, is trying to figure out which sensitive demographic group the first system is using to make its prediction. The whole goal is to teach that first model to get so good at hiding the sensitive attribute that the second AI can't spot it. It forces the main model to rely only on features that aren't discriminatory.
That sounds incredibly complex. But if these technical solutions exist, why are regulators like the EU stepping in with this financial hammer? Why isn't just fixing the tech enough?
Because, frankly, the technical fixes are often imperfect. And sometimes just the opacity itself is an ethical problem, especially when human rights are involved. Which brings us right to that black box problem. If an AI is making calls in criminal justice or hiring or healthcare, stakeholders, the person affected, judges, doctors, they need to know why. If a system can't explain its reasoning, you can't audit it for bias, and you definitely can't prove you're following the law.
Okay. So the solution is explainable AI, XAI. That's the idea of providing clear, human understandable reasons for what the algorithm did. XAI is basically pulling back the curtain so we can finally see the logic, the decision tree.
And that's where the money comes in. For these high-risk applications, XAI isn't just a nice-to-have feature anymore. It's a non-negotiable legal requirement under rules like the EU AI Act. And the really crucial detail for organizations, non-compliance, failing to show why an AI made a critical decision, carries penalties hitting that headline number, $35 million. This shifts accountability. It's not just a tech team problem, it's a C-suite liability.
$35 million, that's a massive fine. That'll definitely focus minds in the boardroom. But the complexity here is technical too, right? You probably can't get perfect performance and perfect interpretability at the same time.
Right.
You have to trade off speed or accuracy for clarity.
You absolutely do. XAI forces this balance between model performance, how accurate it is, and interpretability. You have to choose your techniques. Sometimes you need a local interpretation explaining why one specific person was denied that loan. Other times you need a global approach to show the model's general behavior across everyone. It's a constant trade-off.
Okay, let's shift gears a bit. From transparency to protection. This is a really crucial point for you, the listener. If we can't just centralize all your highly personal data because of global rules like GDPR rules that demand a clear legal reason for processing data, how on earth do these global AI models, the ones that thrive on huge data sets, actually get trained to be smart without breaking those rules? The moment you move data, you create risk.
That really gets at the biggest tension in modern AI, doesn't it? How do we learn collectively without exposing individual identities? Luckily, we're seeing two critical, mathematically solid solutions emerge. The first one is called differential privacy, or DP. It's basically a mathematical framework that adds carefully calculated noise into data sets. Think of it like adding a very precise amount of static, like a mathematical fog, to the
A
information.
mathematical fog.
Yeah, the fog is just thick enough so you can't pick out any single person's details. But it's thin enough that when you look at the whole picture, the overall statistical patterns needed for good machine learning are still visible.
Okay, fog protects privacy, view remains clear. Makes sense. What's the second part?
That would be federated learning. This is more of a distributed approach.
Yeah.
The raw data, it never leaves the local device. Could be your phone, could be a hospital's server. The AI model gets trained right there locally on that client's data. And only the model updates the distilled knowledge essentially are sent back to a central server. This dramatically cuts down the risk that comes with pulling all the raw data into one place.
That sounds almost like the perfect solution. But hang on. If you're collecting the learned knowledge, the model updates, how can we be absolutely sure that update itself isn't still vulnerable? Couldn't it leak information?
That's the catch. You're right. What's fascinating and a bit scary is that those model updates can still leak specific info about the individuals whose data trained them. It happens through really sophisticated analysis techniques, often called membership inference attacks. So even with a distributed system like federated learning, you still need to layer on more protection, which usually means applying differential privacy again, either centrally, at the server, or even locally on the device before the update is sent. Privacy protection is this continuous layered process. It's never really done.
Okay, so the tech is complex, the compliance risk is 35 million, privacy needs constant work. Who in an organization is actually responsible for managing all this? It feels like you need a dedicated institutional approach to handle this whole life cycle risk.
Absolutely. And that's exactly what we're seeing. There's a definite shift towards lifecycle governance. Ethical considerations, privacy protections they have to be embedded right from the start through development, deployment, and ongoing monitoring. This has led to new specialized roles popping up. Things like Chief AI Risk Officers, CAROs, and dedicated AI Risk and Ethics Committees, sometimes called ARs, and they're often borrowing robust methods straight from fields that have dealt with high-stakes ethics for years, like biomedical research.
And these committees, these CARs, they aren't just for show, right? Our sources say they have a specific job to do, like auditing data sets for fairness, for representation, using tools like IBM's AI Fairness 360 to proactively check for discriminatory patterns before a system even goes live. They're actively hunting for the bias.
Precisely. And for those high-risk applications we talked about, the foundational requirement is something called a Fundamental Rights Impact Assessment, or FRIA. This is mandated. It's non-negotiable in many frameworks. FRA forces organizations to really assess the impact on human rights and privacy right at the conception of the system. It shifts risk assessment from being this optional audit you tack on at the end to being a core integrated part of the design itself, which directly addresses that potential 35 million liability.
Okay, we've hit the technical fixes, the legal sticks, the organizational setup. Now for that hidden bonus, the deep dive Easter egg, a technical twist that sounds like it could fundamentally change how AI gets trained pretty soon. Let's talk about the synthetic paradox.
Right. The promise here is potentially massive. We're talking about completely artificial data sets engineered to perfectly mimic real-world statistical patterns, but crucially, without containing any actual personal information. This could solve two huge problems at once: data scarcity in some fields, and the privacy risks of using real data.
And the forecast for this is incredibly bold. Gartner predicts that by 2030, synthetic data will actually surpass real data usage in training AI models. If that's true, that's a seismic shift. Could improve research reproducibility, enhance privacy protection, almost by default.
But there's the paradox. That synthetic data still carries ethical risks, which is the tricky part. If the original real data used to generate the synthetic set was biased, while the synthetic data will faithfully reflect, maybe even amplify, those same biases. Plus, synthetic data is inherently a static snapshot in time. It doesn't evolve like real-world data does. So organizations using it will need really meticulous documentation and governance to make sure their synthetic data sets aren't just high-tech ways of reproducing old inequalities.
And just when you think you've got a handle on things, let's layer on one more future challenge: the sheer speed and complexity of quantum computing.
Quantum. It's not just that it threatens current encryption methods, though that's a huge issue. Even beyond that, the quantum systems themselves present a kind of ethical dilemma in their design. We're seeing that the very properties that make quantum models potentially incredibly fast and highly trainable, their computational efficiency, can also create these subtle weak spots. Weak spots that might allow attackers to potentially extract detailed snapshots of the input data used to train them. So the core challenge for anyone developing these cutting-edge quantum systems is finding that balance. How do you harness the exponential speedup in training while ensuring robust, verifiable privacy protection? It's a tough one.
That's a lot to think about. Knowing that is crucial for grasping the really high-stakes risk environment AI operates in today and tomorrow. Okay, let's quickly recap the value we just delivered here. We've covered how generative AI can give bias a dangerous air of scientific credibility. We explained why the black box problem isn't just theoretical, it's a potential 35 million liability pushing organizations towards explainable AI. We dug into how techniques like mathematical noise, differential privacy, and distributed methods like federated learning are being used to protect your data. And we looked ahead, grappling with the promise and peril of synthetic data and that emerging speed versus privacy challenge in quantum systems.
And maybe one final thought to connect this all to the bigger picture. Remember that AI ethics isn't just about fairness and privacy, vital as they are. Increasingly, it must also address environmental sustainability, the sheer computational power needed for training these huge language models, for developing quantum systems. It demands that our governance framework start seriously accounting for their significant energy consumption and carbon footprints. That's a dimension of responsibility that's really just starting to hit the balance sheet.
That's a fantastic point. This whole ethical landscape is moving incredibly fast, demanding constant assessment, constant learning. Next time, we're diving into something that feels like geopolitical science fiction, but trust me, it's happening right now. How global regulatory efforts are racing to prevent a kind of regulatory fragmentation crisis. Before it totally disrupts everything from international trade to fundamental human rights, you really don't want to miss the deep dive into global governance convergence. Stick around.